everyone to another session of Fashion to Share and Receive at ISLE Indore. This special season where we enjoy mangoes and ice creams and chillers, we also need ACs full time running, daytime, nighttime, whole day through. So why not we save power by switching on to LED lighting than other substitutes which we've been using, and know more about the technical aspects of LED lighting today. I invite the dignitaries to the dais, Chairman Mr. Vinay Babar, our Speaker of the Day Mr. Uday Bode, and the Honorary Secretary Mr. A.K. Mandal. I shall call upon Mr. Rajiv Jain. Please give me a seat. May I now invite Babu for an opening address.
Uninterrupted episode of our monthly seminars. A very warm welcome to you on a hot Sunday morning. I am an optimist. मैं जानता हूँ कि अच्छे दिन आने वाले हैं. Not only us, the entire nation is looking forward to Mr. Modi doing some wonders, and I am sure he'll bring up the markets like never before. Already the Sensex has shown its trend towards rising, and I am sure the markets will improve. And this gives us an opportunity to hold maybe another photon, which we had very successfully held last year, photon 2013, and this year we hope to hold a photon 2014, for which we will be discussing in a meeting with our core committee members after this seminar. And I'm sure we'll be getting a good representation from all the companies from all over India, pan-India. Incidentally, in September 19th and 20th, there is going to be a big seminar at Delhi in Pragati Maidan. That is courtesy IIIT and Elcoma. Elcoma is a key player over there. They are sponsoring the entire event, and IIIT is holding that seminar, which will be inviting national level speakers. I will be extending the invitation to all of you, because the speakers are international, and you may not get an opportunity to hear them otherwise. So it's going to be a nice program in September. Somewhere in October or November, we hope to hold this photon in 2014. Let's hope. We are eagerly awaiting our I Love You man, Mr. Ashok Dubey. He is the key person behind all the exhibitions and a big motivator to all of us. So today's meeting will exclude this agenda. We'll be discussing some other things, and maybe on Wednesday or Thursday we'll keep it in the evening for the core committee. And without wasting much of your time, I would invite you to this enlightening talk by Mr. Uday Bode. It was very nice of Mr. Amrish Kela to assign him for today's talk. He is none other than a manufacturer of LED lights, many fittings in our town itself. So, ladies and gentlemen, have a good morning. Thank you.
He is CEO at ISLE Technologies Private Limited, a scientific group company. He is working with the organization from the last 15 years. He is responsible for overall administration and actively involved in research and development activities for promoting the use of renewable energy products. He is also leading the Clean Tech division of ISLE Technologies Private Limited, which is dedicated for promoting the use of renewable energy using solar and wind technologies and energy efficient lighting. He is regularly involved in field activities and visited various countries to attend conferences and training programs. After completion of graduation in electronics, he has received his master's in business administration and joined this organization at the start of his career. His areas of interest are organic farming, energy conservation, and modern agriculture electronics. We welcome you, sir, to ISLE Indore.
now request the dignitaries to be seated in the front row of the audience.
Giving me an opportunity to come here and talk on the topic LED lighting and its technical aspects. LED is a small, I don't want to, can you hear me last?
Yeah.
So LED is a very small device, it's a solid state semiconductor device, but it is a very huge topic and it is very difficult to talk in an hour or 2 hours on this topic because it includes of electronics, physics, chemistry, all. Electronics in the sense of whenever we are using LED lighting, there will be a driver, power supply, constant current or constant voltage power supplies should be there. So for that we have to have the knowledge of semiconductor theory and voltage, current, everything related to electronics. Now come to this, I was in Bangalore and I was attending a seminar and met a professor, he was a ISLE Bangalore, he was a true lover of LED lighting and a big fan of LED lighting. So very fantastically he explained LED lights, what is LED. Now he explained in such a way that LED lamp, what is a LED lamp. So he explained with a slope that we normally try to at the time of moving my hand in such type of lamp, in front of such type of lamp, which will give me Shubham Karoti Kalyanam, which gives me everything good in my life. Arogyam means health. Since the LED lights are not producing IR radiation and UV radiation, so these are health related issues. Because UV energy can burn our skin or lot of disadvantages are there. IR also having its lot of applications and disadvantages. So it's related to, he correlates the feature with the health, Arogyam. Velasampada, it's an energy efficient device. You can understand a 3 watt of LED lamp can replace a 15 watt of CFL or can replace a 40 watt of incandescent lamp. So definitely it is Velasampada, it is increasing the money also. It's related to wealth also. So in this way, he explained that, that another line is that Shatru Buddhi Vinasha, means enemy's intellectual is the darkness. And darkness, because of its high efficacy, high lumen per watt output, if single 1 watt of lamp is enough to lighten the darkness or to remove the darkness. So in this way he explained. Might be some of you may feel that it is exaggeration of the explanation of the LED lighting, but I love it. Its way of explaining is very fantastic. So you all are the lovers. So I thought that to share this thought to you. So LED, I want to say that the LED is energy efficient device and it's having a lot of advantages. Like it can reduce the carbon emission. It can give us a very good life compared to the CFL lamp. It is having a wide voltage fluctuation capability of working. Means it can start from the 90 volt and then be operated up to 300 volt. So this much voltage fluctuation if takes place, then also it will give us the constant intensity. Otherwise, if we are working with another lamp, then the intensity voltage decreases or increases, the fluctuation, the intensity can be observed. But this is not there with the LED lighting. So, and apart from it, the very big life is there, the 50,000 hours of unlike hours. So 10 to 12 years will be there if you operate it for 10 years, 10 hours a day also. In that case also, so life is very long. And lot of advantages are there, you might be aware of that. But there are some disadvantages also that I should speak on this platform. Disadvantage is the first in the terms of e-waste, because it is containing the arsenic, lead material. So after years it may be e-waste, but I think it should not be the problem because proper recycling procedures are there. Now government is putting a lot of pressure for e-waste management. Second is the temperature dependency, its limitation, because when the temperature increases, the characteristic of the lighting decreases or the output performance decreases. So proper thermal management is again a big question for the LED lighting manufacturers and designers. Third is the disadvantage. I cannot say it's a disadvantage, but its output when the temperature increases and the current increases, semiconductor limitation. I can say that I can explain you during the presentation. So let me start with the first slide. What is the content of my presentation? That is what is LED. I will explain you about the light emitting diode. It's a working principle, that is electroluminescence, making of white LEDs, procedures, how we are making the white LEDs, color rendering index, thermal management, and its power supplies, constant current and constant voltage. I will try to keep my language as user friendly as possible, but it includes my presentation is include lot of electronic terms. So wherever you require, you can ask me any question. So I will start my presentation with the journey of LED. In 1927, when infrared LEDs were developed first, but commercial usage takes place of the red LED in terms of power. Infrared LEDs are very popular for line of sight communication. You all know that. So like for the telephone power switching indicator or on the mosquito repeller or any watch calculator, lot of applications are there for the color LED, which was developed in 1962. Then LEDs are used in torches, then in lamps, then yes, true color RGB displays. These are used. Definitely it's a funny application, but women want the big eyes, so there are some applications like eyelashes also. So you can wear it on your eyes and you can put it off also. So just to increase the size of the eyes. Yes, the journey is not stopped here. The organic LEDs are coming very soon. In fact, it is into the market. We know the Samsung phone is recently launched with the AMOLED. Organic LEDs are having a material that is phenylene, which is embedded between the anode and cathode of that LED lamps, and it is also a PN junction diode, which have a semiconductor material inside. Between that, it's a embedded, it's a sandwich of anode, cathode, and between that the organic material is kept. Now, when we feed the power supply to such type of arrangement, then the current flows, and due to that electron moves and the light emits. These organic LEDs, the specialty is the semiconductor material requirement is of the thickness of 100 to 200 nanometer. This the beauty of this product is that because of its small size, this can be flexible. Even on your shirt, you can embed it or you can integrate it on your shirt also or any fabrics. So it's a fashion also. It will come soon in the fashion also. Organic LEDs are not using right now in terms of lighting, but definitely for the displays and in watches, in car music system, and not many applications. Organic LEDs are used. EPL is it's not a LED technology, but this technology is coming soon. With the field-induced polymer electroluminescent lighting, in which this type of rod will be used, so polymer rod, and its uses of the nanotechnology, in which the carbon nanotubes will be integrated, and because of the high efficiency and high reactive power of this nanotechnology layer, it emits the light, and this technology will start coming very soon. So myth is just, I want to say that people are thinking, even in urban area, people are thinking that the LEDs are Chinese, but LEDs are not Chinese. Maybe because of the decorative lamps which we are importing from China, popularly known as series. So sometimes people think that, but a lot of manufacturing are there now in India. LEDs are available into the market with the different packages, pocket LEDs, small sub-miniature devices, power LEDs, and type of LEDs. Now it depends on user application and their requirement, what type of LED is to be used and where is to be used. It depends on the application. Some manufacturers manufacture such types of LED, power LEDs, power LEDs, and they are defining that this is the whole terminal. This is the terminal where the hole is there. It's positive. Some manufacturers are saying that it's negative. Depends on manufacturer to manufacturer. It changes. That always you have to read the datasheet and before connecting into your circuit. So these are the types of the LED packages available in the light, but LED generates the light. Only the difference between the diode theory is between any simple diode and this LED is that. It is made up of impurities on the semiconductor material. One is N-type and another is P-type. So this N-type material is the negative type of material. P-type material is the positive type of material. Negative type of material is having lot of electrons and positive type of material is having lot of holes. Now, when we connect the supply on this type of arrangement, what will happen? The negative part will repels this electron towards the positive type, and because of this electromotive force, the mobility takes place and electrons move towards the holes. Now electron has to get the energy equivalent to the band gap energy of this junction. So that band gap energy is very much important to understand the LED's technical aspect, because that is responsible for even color emission also. So when this electron energy is increases more than that of this band gap energy, they process this barrier and move towards holes and recombines with the holes. As they recombine with the holes, they emit the light. This is the process of semiconductor charge barriers movement. So definitely when we increase the voltage, there will be a voltage current characteristic. If you want to see it, then if we increase the voltage furthermore, then due to high current polarity to this LED, the current will very low amount of current is flowing, and after one point, again the breakdown region is there. So you cannot, it's a polarity sensing device. You cannot connect it reversely like you are doing with the incandescent lamp. You can connect phase and neutral anywhere, the lamp will light. But it's not with the LEDs. So to see the electroluminescence effect, then because of this recombination of electrons and these holes, the photons are released. And the photons have a particular wavelength, and that is corresponding to the band gap energy of particular material. So that material decides the wavelength because the photon is released. So wavelength means color emission, a particular frequency. So now we can conclude that the color emission from any LED lamp is dependent on the band gap of that material. So if band gap changes, color will change. So people are designers and manufacturers of the LED are putting more work, and they are doing more research and development in maintaining the material's band gap constant as maximum as possible. So you can see that from this, the gallium arsenide is a material having the wavelength of more than 760 material, 760 nanometer, and here is the ultraviolet, like this boron nitride is the material which can be used for making the ultraviolet or violet type of LEDs, which can generate violet color at this particular level. So a relationship comes from this explanation, that is band gap is inversely proportional to the lambda wavelength. So if band gap reduced, then wavelength increases. If band gap increases, then wavelength decreases. So this is the very important equation in the LED lighting and color decision. So here the H is the value of the Planck constant, C is the velocity. So from this chart you can see that the high energy level, for this high energy level, wavelength is small. Small wavelength means high frequency. High frequency means high energy. Okay. Like in RF also we are listening to the radio which is 98.4 megahertz, the carrier frequency. High frequency, high energy, so that I can transmit from one place to another place. So it's high frequency, high energy. This the red color side is the lower energy. Lower energy means here the higher wavelength. Higher wavelength means lower frequency. Lower frequency means lower energy. Okay. So coming on the next part, now it is clear from that how we can make the different colors of the LEDs. How to make a white LED? Now the question is that how to make white LEDs. Colors we understood. There are two ways of making the white LEDs. One is with the combination of RGB LED, and second is using yellow phosphorus of blue LED. These are the two techniques. By using that, we can make the white LEDs. So making of white LEDs, the first method is rarely used method in which the RGB LEDs are taken and integrated optics has been taken over that, so that the color will be the mixing of these RGB and you can get the white light. But this procedure is not in use commercially. The procedure which is used normally is, normally they are taking blue LEDs or ultraviolet LEDs, and on that chip putting the phosphors onto that, yellow phosphor on that, so that the white LED should be emitted from the particular source, and we can have a spectrum from the white spectrum. So different shades of the LED, so we can change the ratio of that phosphor, and we can change the LED's color from the cool white to natural white, neutral white, or warm white. Now it is the question that the white LED has generated the white light, but what is about the CRI? This is the current rendering index. So it is the measure of the ability of any light source in which we can see any object with very true colors or very realistically, like in natural light or sunlight. Like incandescent lamp and daylight are the black body radiators. They show the color of the object very truly. But LEDs, as I told you, that white color, you have seen what is the procedure of making up white LEDs. It is having only the blue color of light and on the yellow phosphorus cap. So that produces the white light. That definitely will not have a good wide spectrum. So definitely lot of colors must be missing there, and we will not be able to see the colors truly. So CRI is affected. So CRI is maybe very poor for such types of LEDs. Now the question is that how to increase the CRI. that is again a million dollar question for these types of manufacturers. So here you can see the effect of CRI. If CRI is low, you will not see the colors properly. True information of the measured colors, and if CRI is 100, like in the blank or daylight, then you can see the colors. So to increase the CRI, what we are doing, or what the LED manufacturer is doing exactly, they are putting, they are taking the blue LEDs and they are putting the yellow phosphor, and after that, so many phosphor layers. So it's a blending.